All right. Good morning, young people. Um, we're about to have an asynchronous day, right? And I want to try something different. We're not supposed to be logging in live today. So I will be logging in by way of the teacher's desk. And I'm going to upload the recording of the two videos that I'm going to make for you all today there so that everyone in all of my classes will have access to everything. Now, I will give you more explicit instructions from the teacher's desk, but I will say it here. I need for you all to type your first name and your last initial and your class period in the comment section of the YouTube video so that I can give you credit for watching the video, for participating in the lesson, okay? And that's for both videos. And then I will give you all an assignment through Microsoft Forms. All right. But again, all of the instructions will be given to you very explicitly from the teacher's desk. Okay. All right. All right, guys. The standard from which this lesson is derived is as follows. Excuse me. SID 2. Use statistics appropriate to the shape of the data distribution to compare center, median and mean, and spread interquartile range standard deviation of two or more different data sets. All right. Today's objective, we only have one. You guys are about to learn how to analyze the mean absolute deviation of a data set. All right, guys. This is where I want you to pause the video and write down the steps for calculating the mean absolute deviation of a data set. Before I talk about it, young people, understand what the mean absolute deviation tells you about a data set. Once you calculate this value, it will give you, on average, how far each data set deviates from the mean of the entire data set. Okay, so what does that word deviate mean? It's how far it strays away, right? So think about a someone who deviates from social norms, right? Who is someone that you like or dislike that deviates from just normal behavior? Someone that stands out, right? And how far do they stand out? Most of the time, people generally tend to clump in the middle. Everyone basically looks, the same with regards to how they present. All right. When you go out in public, you usually dress a certain way and you look a certain way. Okay. Would it be bizarre if I showed up to Walmart in a ball gown? Okay. That would be a deviation, would it not? Because normally when people go to Walmart, you just, have on a pair of jeans, some tennis shoes, comfortable shoes, a shirt, whatever. It's whatever, right? No one's dressing up in a ball gown going to Walmart. Or, uh, if say I was going to a gala, some sort of, fancy soiree, right? And I showed up in a bonnet cap, right? Okay, in a bonnet and my house dress and some flip flops. Now everybody else has on ball gowns, right? But I have on a bonnet, right, or a wrap cap or something, and some flip flops, right, and my house dress. That would be a vast deviation from the norm because everyone there is dressed up and I'm the only one. Now back to mean absolute deviation. Again, this value tells you how each point or each element of a data set, okay, how they average from the mean of the data set, okay, how far they deviate from the data set. All right, and so we'll do an example or two to make this real, okay, because right now I'm speaking quite abstractly. All right, so step one in calculating the mean absolute deviation, and you will see this referred to as MAD, all right? Know that they're referring to the mean absolute deviation. So step one, find the mean, find the average of for the entire data set. So that means adding up all of the numbers and dividing by the total number of numbers. Okay, y'all know how to do that. Okay, we're back in middle school with that. So the next step, young people, once you find the average, once you find the mean, you're going to subtract the mean from each data point, right? You're going to subtract the mean from each data point. And whether it's positive or negative, you're going to take the absolute value, okay, of that difference. All right, so step 2 literally says find the absolute value of the difference between each data value, x sub n, and the mean. Okay, so these weird symbols, you see those 2 lines on the outside, that means absolute value. The x with the line over it, that's the symbol for mean, okay, for average. And x sub n, that just represents each element in the data set. So x sub 1 will be the first entry, second entry, x sub 2 will be the second entry, and so on and so forth. We're going to make it real in just a second. All right. Step 3, find the sum of all of the values in step 2. So once you subtract once you subtract the mean from all of the data points, okay, you add them up. You find the sum of all the values from step 2, okay? And then step 4, then you divide the sum, okay? Divide the sum of those numbers, okay, by the number of divide the sum from the previous step, okay? Sorry for being confusing. Take that number, once you add up all of the differences, okay, you take that number, you divide it by the total number of the data. So you find the mean twice, really, okay? You're finding the mean twice, all right? And this is the formula for MAD. I know it looks weird, but all they're telling you to do is take the mean and subtract from it each data point in the set, add them all up, and divide by the total number of data points in the set. All right, let's make it real. Let's go. All right, so here's the situation. A rescue agency records the number of pets adopted each month. All right, so the data they collected is as follows: 14, 18, 12, 17, 15, and 20. All right, these are all of the number of pets that they adopt each month. So I'm guessing this is month 1, month 2, month 3, month 4, month 5, and month 6. So they want us to find and interpret the mean absolute deviation. All right, give me a second. I'm going to go see if I can get my writing pad. Hold on. All right, guys. So hopefully my handwriting won't be too weird on here, but we'll see how it goes. I'm going to thug it out. All right, so let's find the mean absolute deviation. So what's the first step? You all should have written it down, right? So the first step is to find the average of the data set. So I'm going to add 14 plus 18 plus 12 plus 17 plus 15 plus 20. Okay, add them all up and divide by the total number of numbers. So there are 1, 2, 3, 4, 5, 6 numbers in the data set. So I add all of them up and divide by 6, right? Okay, find the mean. All right, here we go. Oh, I may not need my pen at all. All right, so check it out. They found the mean. Remember the X with the line above it? That's the symbol for mean, for average. All right, so the average of this entire data set is 16. The mean is 16. All right, cool. So once I find the mean, what's the next step? I'm supposed to take that value and subtract from it each of the values in the data set, right? Now, the text does something interesting. To avoid the need to find the absolute value, they always just put the bigger number first, so that when you subtract them, you always end up with a positive number. But it doesn't matter. It doesn't matter what order you go in, guys, okay? I can say 16 minus 14, or I can say 14 minus 16, okay? Okay, this is the first number in the data set, right? I can say 14 minus 16 equals negative 2, right? And then when I take the absolute value of negative 2, that's equal to 2. You feel me? Or you could just say, okay, 16 is bigger, so I'm just going to say 16 minus 14 equals 2, and I'm done. That's my difference. Okay? All right, so next step. Let's go ahead and make it happen. Find the absolute value of the differences. So remember, I'm taking the mean, which is 16, okay, and I'm subtracting from it each of the data points. So let's do that. Okay, bam, that's the first one. 16 minus 14 is 2. 16 minus 18 is actually negative 2. So the absolute value of negative 2 is positive 2. All right. 16 minus 12 is 4. Okay, and that's what these lines mean, guys. That means absolute value. I wish they would have put more space here so you can really see what's going on, because that just looks like a funky looking H, right? But whatever. So this actually says the absolute value of the mean minus data point x sub 3. So whatever. 16. The absolute value of 16 minus 12 is 4. The absolute value of 16 minus 17 is positive 1. All right, the absolute value of 16 minus 15 is positive 1. Remember, I know 16 minus 17 is negative 1, but once you take the absolute value, it becomes positive 1. Keep that in mind, okay? And then the last data point, 16 minus 20 is negative 4, but the absolute value of negative 4 is positive 4. Okay, so we found all of the differences, right? So now once you find all of the differences, and I kind of went a little fast, sorry about that, y'all. Once you find all of the differences, all of the numbers that you got after you subtracted, you add them all up, okay? You add them all up. So you take each of those numbers, the 2, 4, 2, 2, 4, 1, 1, and 4, add them all up, right? And who remembers what to do with this number, okay? Once you add them up again, you're really finding the, like I said before, you're finding the average, you're finding the mean twice, okay? So you take that 14 and divide it by 6, okay? Okay? Because that's the total number of numbers in the data set, all right? And 14 divided by 6 is approximately 2.3. So the mean absolute deviation is 2.3. So what does that mean? On average, each data point deviates from the mean about 2.3 units, okay? About 2.3 units. That's what that means. So a mean absolute deviation of 2.3 indicates that, on average, the monthly number of pets adopted each month is about 2.3 pets from the mean of 16 pets, like I said before. That's the deviation of each element of the data set. Okay? All right, let's look at another one. All right. So let's talk about it. Let's talk about it. Let's work one out. I'm gonna white all of this out, okay? And then we can work it out together on here, okay? Let me see if I can get a I wish there was a way for me to just like cover this up real quick, but I don't think I have that option in this interface. How about this? How about it's going to be really bootleg, y'all. I apologize in advance. But I'm just going to write in between, and we're just going to talk through the steps for finding mean absolute deviation. How about that? Okay? Because technically in class, this is where I would press pause and let you all do one on your own, right? So let's just walk through it together, all right? So step 1 in finding the mean absolute deviation. First thing you do, you see the data points there, 14, 0, 20, 24, 17, and 30, right? The first thing we're going to do is find the mean of this data set. So how do you find the mean? Well, I simply add them all up, and I divide by the total number of data points, right? So let's do that. So I have, let's see, 14 plus 0 plus 20 plus 24. Didn't really have to do the 0 in there, huh? But just do it for good measure. Plus 17, 14, 0, 20, 24, 17, plus 30. Okay? And that's equal to 105. And then I take the 105 and I divide it by, how many total numbers do we have? 1, 2, 3, 4, 5, 6 divided by 6. All right, and so my mean is 17.5. So I'm going to write this at the top. I'm going to say X with the line means mean, right? It's 17.5. All right, cool. So what do I do with this number? Well, I take that value, right? I take this value and I subtract from it each of the points in the data set. Okay, so let's do that. So what I'll do is I'll just line the top with those values, with those differences, okay? All right, so 17.5 minus 14, okay? That equals 3.5, so I'm gonna write 3.5 right here. That's the first one, okay? And then I'm gonna say 17.5 minus 0. That's 17.5, right? Okay. And then I'm going to say 17.5 minus 20. Well, that's a negative 2.5, but the absolute value would give me a positive 2.5, right? All right. And then 17.5 minus 24 is a negative 6.5. And the absolute value of that would just be a positive 6.5. So I'm going to write that here. All right. And then I have, let's see, 17.5 minus 17 will give me 0.5. Okay. And then finally, 17.5 minus 30 will give me negative 12.5, and then the absolute value of negative 12.5 is a positive 12.5. All right, so these are all of my numbers, okay? These are all of my differences. So what's the next step? Remember, I said you're really finding the average twice, right? Once you find all of the differences, and the reason why I spaced them out, because we're going to add all of these puppies together, right? Going to add them all up. Gonna add them all up. All right, so that's gonna be 3.5 plus 17.5 plus 2.5 plus 6.5 plus 0.5 plus 12.5 equals 43. All right, and then I'm going to say 43 divided by the total number of differences I have. So I have 1, 2, 3, 4, 5, 6 divided by 6. And that's equal to 7.16 repeat, right? So I'm going to round that. So I'm going to say instead of that, well, I forgot to write the sum. What was the sum, y'all? Oh, wait, let me just say times 6. All right, so this is equal to 43. All right, so my mean absolute deviation, I'm just going to write it here. Let's do it in a different color. I'll do it in Westlake blue. Well, no, I'll do it in purple. Okay, it's not that serious. All right, the MAD is approximately 7.17, right? What did they say? Find and interpret. They didn't say anything about rounding, but it seems okay. We got 7.17, but all I see is 7.2. Okay, so that tells me that we're rounding to the nearest tenth, even though I don't see that explicitly explained, but that's okay. All right, so this becomes, I'm just going to do an arrow, and that becomes 7.2. All right. So the mean absolute deviation is 7.2. So that tells me that each of these data points, all right, and I just realized I didn't even read the doggone problem to y'all. All right, let's talk about it. It says a statistician reviewed the number of points his high school team gave up at their home games this season. Okay, so they gave up 14 points one game, 0 points one game, 20 points in another game, 24, 17, and 30 points these other 3 games. So we found the mean absolute deviation, okay? So what does this mean? It means that each data point deviates from the average, which is here, deviates from the average 7.2 data points, okay? So what does all of this mean? Okay, on average, the number of points given up was about 7.2 away from the mean of 17.5 points. Now, I know you see 7.2 in other places, right? I see 7.2 here. I see 7.2 here. And that's it. All right, so let's look at those other choices and make sure that we don't get caught up. So the first one says a team gave up on average 7.2 points per game. Is that what that's saying? Okay, because technically, for that to be a true statement, how many points on average did they give up per game? We found the initial average, 17.5. On average, they give up 17.5 points a game, right? So that's not what that number represents. 7.2 doesn't represent how many points they gave up, okay? Look at the answer choice B. It says, on average, the number of points given up was about 7.2 away from the mean of 17.5 points. Okay, that sounds good. Yeah. So then it goes on to say, this is affected by the outliers, 24 and 30. Now, we haven't talked about outliers, okay? We haven't talked about outliers. But they said that 24 and 30 are outliers. An outlier is a number that's way off from all of the data points. The reason why I have a problem with this statement is because 24 is certainly not an outlier. Okay? Certainly not an outlier. If I were to choose an outlier in this situation, I would choose 0. Okay? And potentially 30. Because it's so far away from 17.5. You understand what I'm saying? They're so, well, I wouldn't even choose 30. I wouldn't even choose 30. 0 is the one that's way off. Okay? Because it looks like on average, this doesn't seem like a too sharp of a team because they give up points 5 games out of 6. So this one time that they didn't give up any points, that's unusual. Okay, that's unusual. Even though 30 is kind of large, it's not too far from 24, and 24 isn't too far from 20, and 20 isn't too far from 17, and 17 isn't too far from 14. Do you understand? But 0 is way far from 14, the next biggest number of points that they gave up. You feel me? All right, and then part D says on average the team gave up 17.5 points per game. That's a true statement. Okay, that's actually a true statement, but they didn't ask us about the average. The point of this was not to find the average of the data, but to find the mean absolute deviation and what the interpretation meant. Okay? All right, let's move on. And young people, even though this is asynchronous, feel free to post questions or concerns in the chat section, okay? All right. So, next slide. Young people, this is your homework, okay? I want you to take a moment to either take a picture, take a snippet, take a screenshot, what have you, okay? And we're going to use this to complete your homework that I'm putting in Microsoft Forms, all right? That link will be posted, okay? That link will be posted by class period in the teacher's desk, okay? That link will be posted by class period in the teacher's desk. All right, so you can pause the video here. I'm going to go ahead and end, but this is the problem that I want you guys to complete for today. All right, I guess I can go ahead and read it for you. All right, so this is a problem that I extracted from your textbook. All right, and so it says Mr. Day has another jar of pennies on his desk. Okay, pennies. There are 30 pennies in this jar. Theo chooses 5 pennies from the jar. Lola chooses 10 pennies, and Peter chooses 20 pennies. Pennies are chosen and replaced, okay? Oh, excuse me. Bless the teacher, y'all. All right. So Theo's pennies are as follows. Find the mean absolute deviation. Lola's pennies are as follows. Find the mean absolute deviation. And there's Peter. Find the MAD for Peter as well. And then part D, which is a bit of a doozy, I know. But I want you to find the mean absolute deviation for all of the pennies in the jar. And then in class come Wednesday, we're going to talk about how the mean absolute deviation for all of the pennies compares to Peter, Lola, and Theo. But this is what I want you all to complete in class. Questions or concerns? Be sure to post them in the chat section, young people. All right? Do your work. Bless the children. I bid you adieu. Bye, y'all.